Today is another day God has made in our lives, and this is OBED'S tutorial. Today I am taking you through terpenes and terpenoids. Terpenes and terpenoids have happened to become one of the natural products that we have, or they have happened to become one of the secondary products. And this secondary product or the natural product, they are that compound that have no primary benefit for the plants or for the source survivor or the survivor of where we extracted them from, but they are of use to other organisms, or they have their own biochemical effects. Okay, today looking at terpenes and terpenoids. This this is OBED'S tutorial. Kindly subscribe, like, and comment. So when we talk about terpenes, terpenes are those chemical compounds or organic compounds or secondary metabolites that are found in plants and insects or other sources that we may come across. And these terpenes are synthesized from two or more isoprene units. They are synthesized from two or more isoprene. These isoprene units is a 5 carbon compound that is in biosynthesis terpenes. So we get there. And we also have terpenoids. Basically, terpenes are hydrocarbons in nature, they are hydrocarbons. So anytime we introduce oxygen to these hydrocarbon terpenes, we form something that we call terpenoids. So terpenoids are those terpenes that contain oxygen. So this oxygen presence in these terpenes, they might be in the form of aldehyde, ketones, or alcohol. That's terpene. So we have the structure classification. Structure classification. Earlier on, I mentioned that terpenes are normally synthesized from the isoprene unit, and I said that the isoprene unit is 5 carbon compounds. They have molecular weight of they have molecular formula C5H8. That's their molecular formula, and they are the fundamental precursor for the synthesis of the terpene. Okay, so they come the terpenes normally have molecular formula of C5H8 bracket close end, where this end represent the number of isoprene units in that terpene chain. Okay, so now we are classifying the terpene based on the number of isoprene that they have. So they can have one isoprene, two, three, four, or more isoprenes. For that reason, each isoprene that the terpene contains will determine its name. Okay, so any terpene with one isoprene unit, or let's say 5 carbon atoms, we call it hemiterpene. And terpenes with isoprene of 2, call them monoterpene, or in other words, terpene with 5 carbon atoms. We call them monoterpenes. Three isoprene, which is 15 carbon atoms, is called them sesquiterpenes. And also 4 isoprene, which is 20 carbon atoms, we call them diterpenes. 5 isoprene units having 25 carbon atoms, we call them sesquiterpene. And 6 isoprene carbon atoms, we call them triterpene. So now, this is OBED'S tutorial. Please kindly subscribe, comment, and like, and make sure you turn on the notification bell. Anytime I'll post a new video, you'll be able to get it fast. So please, guys, write the name for a terpene with 7 isoprene or 35 carbon atoms in the comment section. Okay, so any other terpenes with 40 or more carbon atom, or 8 or more isoprene units, we call them polyisoprene. We call them polyisoprene. Okay, we also have some of the names that we've looked at in a previous session. We talk about monoterpene, sesquiterpene, these are the structural classification. So this is the isoprene unit, the isoprene, and this isoprene, as I said earlier, 5 carbon compound. Okay, and let's see whether it contains 5 carbon. That is 1, 4, 5, 5 carbon, or 1, 2, 3, 4, and then 5 carbon atom isoprene. So if you join isoprene, you get the terpene. For instance, I've joined the 2, I'll get monoterpene, 10 carbon atom. Then since the isoprene is 5 carbon atom and they are the basic or fundamental precursor for the synthesis of terpenes, the terpene that is formed from the isoprene unit will have multiples of 5 carbon. Okay. So these are the structural classifications of terpenes. We have monoterpenes containing 10 carbons, sesquiterpenes 15 carbons, 3 isoprene units. So this is 1, 2, 3, 4, 5, 1 isoprene unit, 1, 2, 3, 4, 5, 2 isoprene units, 1, 2, 3, 4, 5, 3 isoprene units, 5 isoprene units. And the terpene can also be in cyclic form. For instance, sesquiterpene condenses or arrange itself to form a cyclic compound. No more sesquiterpene, but rather cyclic sesquiterpene. Let's take note of it. These are some of the examples of terpenes that we have based on their structure. Okay. Let's also look at the examples of the terpenes. Some common terpenes that we know, their sources, the aroma that they produce, their effect, and also potential health benefits. So now, our first terpenole, that is a terpene that we find in apple fruit. Terpenole, terpene that we find in apple fruit. Then we have this citrusy scent or aroma, and these terpenes are known for their energizing effects and also uplifting and calming the body. You get it? So these are the effects of the terpenole. We also have antioxidants, anti-inflammatory, and antimicrobial effects in the body. Yes, they fight for micro or microorganisms in the body. Okay. The second one is mycin. Mycin is also one of the examples of terpenes that we know. It is commonly found in mango fruits. It has this maxi earthy smell and also have elevated relaxing and soothing effects in the body or on the any organism that is fed that has fed on the mango tree, mango, and it has this re- reduction muscle bounce and pain effects. So it has a health benefit reducing muscle spasms. And we also have the other terpene that we have, which we may come across, but we don't know it's a terpene. We have it is called lemony. Normally found in citrus fruit, oranges, lemons. We find lemon. It has this citrus aroma for energizing and stress relieving and mood enhancing effects in the body. And also it has anti-inflammatory, digestive and antioxidant. Normally um, beneficiates normally advise us that anytime we eat, let's try as much as possible and take in something like citrus fruit. Citrus fruit contains a terpene lemony which helps with digestion of food that we eat. We also have the other examples of terpene that we call humulene. Humulene, it is found in fruits, and this terpene has earthy, woody, and herbal spices aroma. Okay, it calm and relax. This terpene also have a health benefit of appetite, suppressant, and analgesic. So these are some of the examples, the uses, the source, and the effects, and also the aroma of some common terpenes. Okay, alright. This is OBED'S. Kindly subscribe, like, share. Make sure you turn on at any time I post a video, you'll be able to get it. So now we are looking at the characteristics of terpenes and terpenes. What are some of the features? Now if we come across any compound, we'll be able to tell that this compound is terpene or terpenoid. So we are going to look at these features of terpene. So that anytime we are doing research, we are doing our lab work, we come across any compound, we'll be able to know that oh, this compound is a terpene. So let's look at some of the characteristics. The characteristics of terpenes and one they have specific terpenes normally have figure based on the type of terpene that you have or the examples of terpene that you have. Look at it earlier on. For that reason, they are used in perfume manufacturing, production, and also medicine. Okay, some medicinal, that's what they are used. They are also synthesized from isoprene. Said it already. Terpenes are normally synthesized from isoprene. This is isoprene. Normally, isoprene has this structure, for isoprene, and it comes head and then tail. Head is the branch end of this isoprene, and then the tail is the unbranched end. Or in other words, can see head is the white side of the isoprene, and then the other one apart from white. So these terpenes are synthesized by connecting two or more isoprene. Are you getting it? So when you connect or more isoprene, you form terpenes. So normally terpenes are being connected using say that when nature terpenes occur as head to tail connection. So in nature you get head to tail connection in all natural terpenes. But also in any other terpene, synthetic terpene, they connect either by head or head head to head or tail to tail connection. But in natural terpene, they connect or they are joined by head to tail. Okay. Terpenes are also still volatile, meaning that anytime we expose any compound or terpene to heat or high temperature, it tends to volatilize. Okay. For that reason, the best method for the extraction, the best extraction technique is distillation. Okay, so my previous video, I we discussed what steam distillation methods is. Okay, what are the method processes and how it's okay, how to extract it. Kindly follow, subscribe, like, and share. So you turn on the notification button so anytime I upload content, get it fast. Terpenes are also easily oxidized. Terpenes, as I said earlier, they are actually hydrocarbons. So if it is exposed to oxygen, it will be oxidized to form what we call the terpene. So as I said from the definition, terpenes are terpenes are oxygen oxidation, get it off oxidation, and the terpenes also have multiples of 5 carbon. Since they are synthesized from isoprene which contain 5 carbon atoms, definitely if you connect this isoprene have a multiple of 5 carbon atoms. Okay, and also as I said earlier, they are being connected by head to tail in every natural terpenes. By in synthetic terpene you can have head to head or tail to tail. Okay, OBED'S subscribe update. So now my next video is on how to identify terpenes by using isoprene. So it's based on how to identify terpenes in extraction, cyclic structure. So in that video, we'll discuss or show or we circle the terpenes in extraction. Get it? Thank you for watching. Subscribe, like, and share for more. See you. Bye bye.